Welcome to developing a UAV drone swarm week 6. If you don't know the series, I am 19 years old and I'm trying to develop a VTOL UAV that can fly for 2 hours, hover for 10 minutes and carry 5 kilograms worth of payload, which for the moment can be used for humanitarian missions, for example feeding people in the Gaza area or delivering goods at Ukraine's front line. And after we got all this done, we have a base model where we also want to build attachments that you can slide in the drone at the places where you would usually have the payload, with all sorts of interesting tech, for example search and rescue gear and stuff like that. We want to do all of this extremely cheaply, and we have a lot of interesting ways where we can do that and try that, but we'll probably see that in the future videos. So welcome to week 6. Today we are going to make a new trailer of this entire project, because I created a Patreon and I need to start thinking about funding certain things, because currently I'm not making any money with YouTube or anything at all. We're also going to determine a few of the minimum size requirements for all of the electronics we need, the internal payload size, the bomb bay door mechanism, and we're going to get an explanation from a very smart guy that is also leading a UAV project, and he's going to help us out with how we can quickly make prototypes in OpenVSP and test it out with like some very easy aerodynamics equations and stuff like that. All in all, very important. If you do anything in this field, I think it's worth watching. Although I'm still a noob, I started learning everything 6 weeks ago, but I'll stop talking. Welcome. Hey there. I'm working on a new trailer for the drone project, but also to promote my new Patreon. Last Sunday, I randomly started working on it, and at this point, I just want to make sure that it's the best trailer possible. So I'm really going to make a good trailer. I really enjoy making some stuff in Blender. I use some AI voices. Last video did pretty well pretty quickly, so I got a lot of emails, so I still need to reply to a few. Thanks everyone for reaching out. There are 20 people in the Discord server right now, and a lot of development is happening as we speak. For example, yesterday we started on a side project where Xenos is working together with a few other people to develop the technical side of things. Think of custom PCBs and software, but we are also thinking of making an alternative to GPS with object detection, compass, other sensors, all to make sure that the drone can still fly and get to its destination when it's being jammed in those kinds of areas where it's meant to operate, which is absolutely amazing. Thanks to everyone that is contributing in other fields as well. And also special thanks to Josh for helping me manage a lot of these things. I'll go into that a bit later. So the Patreon will already receive this video and see the first bit of the trailer. So when this is uploaded, I think the trailer is already done, but I basically need to now make shots of this portion.
Make the future something to look out for. My eyes, ambition is the sun to my solar panel, an endless source of energy which can be used to outshine any competition, to work out every issue you see and find a solution, to rapidly learn whatever is on your path, to have an advantage over anyone without continuous energy. Why would I let anyone steal my solar panels? They're expensive after all.
So the first shot I want to make with in my eyes, I want to make goggles in Blender, and then like you fly through the goggles and then you get to a different scene and there you have like a big sun. It's basically all going to be space themed. I've been drawing it out a little bit in Paint to get a better idea of what I want, but I think it's pretty clear now. So I'll go ahead and model some stuff. Alright, so these are the glasses. They're a little bit glitchy and I don't know why, and I'm not going to fix it. But the idea is that like I think this shot will be like this, and then binoculars will be like floating around, and then the camera flies through one of the glasses and goes right in here, which is green, so I can use a green screen to go to the next shot. So let's go ahead and animate that. Okay, so this is the animation. Alright, so I did all of the settings and I think I'm ready to go render. I really enjoy making stuff like this, and I'm honestly really excited to see how this video will end up becoming. All of the Blender files will be put on my Patreon for the $15 a month package, where you get all of the previews and sneak peeks, and you would have already seen my trailer before it was done, stuff like that. So you should definitely go ahead and subscribe. Link is in the description. It's great. And that's what this video is for as well. It's like a really cool advertisement for my project and the Patreon. Because like I said, there's a lot of cool stuff going on in the background, but it's a lot to manage, and I kind of need to start thinking about how I'm going to fund this project and how I'm going to manage this project. Because I need to be prepared to actually start testing things in real life, and I'm only 19. So in the meantime, I also quickly modeled a sun, and then I added all the clips together, and it looks like this. Pretty damn cool in my opinion. So for the part where I say like the ambition is the sun to my solar panel, I want to create like a cool sci-fi spaceship with solar panels on it. And I took it a bit too serious, so enjoy watching me build a spaceship whilst I'm talking about the other stuff I did. Now, obviously, we also need to do some development in the meantime. So what are the plans for this week? Well, me and other people are really excited to start working on OpenVSP and trying out actual plane designs. But there is still some unfinished work from last video that we need to finish and summarize, and there is a few more things that need to be done. So if you weren't there the last video, first of all, you should go ahead and watch it because that's good for my views. Second of all, why didn't you watch it? Third of all, so what we did is we were looking for different requirements that we need to know before we actually start working on the project, on the design. Because if we don't know how big the payload has to be, for example, then yeah, we're not going to get far. What we got from last video is that we tested out a bunch of payload sizes and we put them in Blender and looked at like how big it is and how we can determine how big of a box you need for certain items. So we found a solution for that by just making a density rating. Now I think that's going to be a bad idea based on the things that we tested this week, which I'm about to show you. So we need to continue with that, and we also need to determine on how big the internal payload should be. So when we have this information, we know how big the fuselage has to be at minimum. So let's go ahead and start with that. First of all, let's imagine that this is the fuselage, very aerodynamic. The fuselage needs to have a lot of things to be kept in mind. First of all, we need to know how big the electronics are and how much space we need to leave for the electronics. Think about the flight controllers, the cameras, the sensors, and for object detection you need some strong microprocessors. We might even use two. So I did ask Cluster to do some research on this last video. To be fair, these are a bunch of electronics that are randomly picked, so don't take them too serious, but it should give us a good idea of what it would weigh, what it would cost, and what the size is. It's just very rough. So I put all of the dimensions in Blender again with the maximum sizes of the fuselage again. So 3 meter wingspan and 1.7 meter fuselage. I kind of want to go a bit smaller than that for the fuselage because I think we can. As you can see, the electronics box here is very small. And that's a box where I left like probably more than 75% extra space. And I tried to put the electronics a bit weirdly because you can never like have the most optimal spacing, if that makes sense. So yeah, I think a box like this should be enough for now. So if we at least keep something like that in mind in the fuselage design, it should be good. So that is 11 centimeters by 6 centimeters by 9 centimeters. I already showed this to the electronics guys and they said it should probably be good enough and enough room, at least for now. Okay, so we got the sizes for the electronics box. What else do we need? Well, like I just mentioned, we need to figure out how big the internal payload should be to fit most of the items that you might want to export or like transport. Obviously, we are planning on making an external box. So, I mean, it makes more sense in my opinion to like be able to fit like dense items. Think of radios, cell phones, batteries inside of the fuselage, and at least as many of the items that you can without being too large. And I think like a lot of people think at least that the external payload, if we make it a bit aerodynamic, should not have a huge drag increase. So I think we should definitely be using the external boxes pretty much. Obviously, I also did some research on that. Some pretty extensive research actually. First of all, we had a few AI examples last week where AI just guessed how big and how dense certain items are. Now I asked Aryan to just look it up and like put real data in a list so we can actually test stuff out without making stupid mistakes because of AI. So he went ahead and did that and even made this funny video of it. So then we had an entire list. So I wanted to see how many items I could fit. By the way, he also made a very nice best fit graph. I'm still really bad at graphs. So this axis is volume and this axis is density. You can see that a lot of the items actually are in the lower volume level. So that's really good. That means we can hopefully fit a lot of the items inside of the fuselage itself. So I just didn't take this one actually. I wanted to, but it's very big. And then I just started with these points and adding them inside of Blender. Now this is the biggest item I added in Blender, which are the portable stoves. So this is pretty big, but it still fits. I mean, we could do it, but the question is it worth it? These are the smallest items, for example. And yeah, I tested a whole bunch of items. It took some time. I did a lot this week now that I'm thinking about it. So as you can see, I got the Blender project in front of me right now. So this is the 100% to 85% payload space used up. So basically what I did is I started with these portable stoves and then I tried to fit every other item in the same space where this fits. And I basically only looked at the volume of each item and then the 5 kilograms worth of that. And every single item in the list that he made fit inside of the fuselage. Now you can see in these three, about 100 to 85% of the payload space is taken up. I did eyeball these numbers, but I guess it's accurate enough. Now in this segment, the next one, the items become smaller basically exponentially. So this was the last item and then we went to this. So we went to like 85% utilized roughly to 60% utilized to 45%. So in this section there's 3 planes and in this section there's 4 planes or 4 items and it gets smaller very rapidly. But then we get to the next section which only uses 15 to 5%. And that's a lot of different items fit inside of that. So the question is, do we make it only this segment? Like, why would we have such a big payload if a lot of the items that we have at least would fit in this already? Or should we also make it fit some of these or like everything? I don't think we should do everything. So I would say that we take this item, we should make sure that this one fits, which is solar panels. And if this one fits, then the water purifying tablets, the power banks, the ammo boxes, the radios, and the smartphones would all fit inside of that space. And I think that's a pretty good thing to have internally, because for the less dense things, it just makes sense to have an external payload and not have it too big for no reason. So I think we should take this one. So let's go ahead and figure out how big that is. I will be able to add a bit of excess space because you never know. Okay, I think a box like this does make sense. So what are the dimensions of that? So that should be 0.01 cubic meters and 10 liters. I'm pretty sure you do comma for this, because when I put it in like M3 to liter calculators, it would say 1000 liters. But then when I put it like this, because that's not possible, when I put it like this, it was 10 liters. So yeah, it's a bit weird. I must have done this wrong in previous videos. I apologize. So we now figured out the size of the fuselage payload. Now we kind of have to think about how thick the walls have to be, at least for the plane, or like how much we should keep up in mind. I would say 2 to 3 centimeters, but I think that's quite big, especially for the payload bay, because of course, if you look at it from like the bottom, if the payload bay would go here, this would make this very thin. But I do think we need at least 3 centimeters there. Yeah, I think we do. Okay, I'm just gonna say 3 centimeters for all the walls at least. I ended up talking to Jonathan and he said that we don't really need 3 centimeters. Like we don't really have to define that right now, and 3 centimeters is very big. He said we should just work in OpenVSP and find something and get like the gist of it. So it's good we have the requirements that we already have, but we don't really have to think about how big the walls have to be until we know more about how we're gonna make the walls. So I will leave that behind for now. Don't mind whatever I drew on this side, I'll get into that later. But I also had to determine how big the payload dropping mechanism will be. You need to have like some sort of a hook or something here, or maybe even at multiple places that automatically latch so that the payload can drop. But we also kind of want to have like a payload mechanism, like bomb bay doors, you know? So to turn those doors, we need servos or motors here. And for motors, you need like a drive system for each motor. So I had a call with Josh and I just asked him to very roughly estimate those sizes because he's going to be responsible for the payload system, and he's also going to work on trying out our foam idea. Now, about our foam idea, it might be a bad idea. I had a call with Jonathan, and Jonathan has been helping us out also in the past few videos, but I haven't found time to properly show what we talked about just yet. But basically, he is really amazing, and he is a student, and he is also working on a drone project. He is trying to develop with a team of other students the fastest, the world's fastest drone or UAV under 25 kilograms. But this guy is really smart. I'll show you his website. So this is their Instagram page, Super Aero CH. They're based in Zurich, and this is kind of what their plane design is right now. They implemented features of an F-16 and the Concorde, and their Instagram is actually filled with a lot of information that's actually very interesting. So their goal is to reach 1,050 kilometers an hour, or Mach 0.85, and they're going to be using a jet propulsion for that. Honestly, please go ahead and click the link in the description. You'll get to his Instagram page, and you can follow him there to show him some appreciation for what is about to happen in this video, because me and him had multiple calls. The first one I didn't get to yet, but he basically made a Python script for something very useful that we aren't getting to just yet, but I'll show you whenever we get to that. This week we also had a call, and he was basically explaining us everything we need to know to go ahead and try out different concepts in OpenVSP. What did he teach us? Well, basically the basics of designing planes in OpenVSP, how you make the wings and all these settings that are useful, things that I actually didn't know, and very useful things as well, like how you can edit the subsections of the plane. And then he explained another part of OpenVSP where you can basically simulate a whole bunch of stuff. Now, I forgot all the terminologies, but I'm not going to over-explain everything. I'm just going to show you the most important parts of that call, so you guys also learn something from it. I will be chopping the entire thing up so I can put it in the Discord server for people that are helping out. So they also have a very good tutorial for what we have to do. Basically, based on his explanation, we can determine the speed that is most efficient and the range that it would have based on the batteries, with a few very complex equations that he explained to me. Now, I was always very bad at math, but with his explanation, I actually understand it now. So that means you should too. So I cannot fit the entire footage in this video, but the entire footage will of course be in Patreon. I'm going to be annoying like that. Yeah, so enjoy.
I have to explain a bit. So I already drew some curves which you can get from OpenVSP. So the first curve here I drew is the lift over drag curve, or the so-called drag polar. So it relates the lift coefficient to the drag coefficient, and that is specific to your design, right? Using that curve, you can see what kind of drag you have with a certain lift and vice versa. If you want to fly most efficiently, so by flying most efficiently, I mean flying the longest duration. For that, you need to draw the tangent to this curve, and then point where you touch the drag polar. That's the point at which you are most efficient for flight time. So the lift to drag ratio is equal to the coefficient of lift to coefficient of drag ratio. That's the same thing.
So because I'm still a little bit confused with how this all works, I decided to do a little bit more research on it, and this is what I understand of it right now. I was a bit confused with what the drag polar even meant in the first place. So I just quickly drew this out. This might not be a very realistic one, but so first of all, the horizontal axis here is the drag, and this space, so this is the lift. So the space in between the start of the graph to the beginning of the drag polar is something called the CD0, which is basically the drag that you will always have. And then wherever this graph starts is just a drag that comes from the lift, I think. So when you draw the tangent, which you do from 0, you can see that right here, roughly, it touches the drag polar, which means that at this point, you get the most lift for the least drag, basically. So it's kind of most efficient. Now, you only get that at a certain speed, I believe, which is why you would calculate this, and why this number is very often used in calculations that are important. So let's continue with the video.
Right, so if you have that, you know at which ratio you have the best flight time, but which is not the best range. And what I remember from my classes is that it's not trivial to find the best range, but there are approximations. The approximation you could do is with the thing I sent in the chat with the Frege range equation. So this one here, right? Given that it's true. And I mean, I guess you can try to work with that first because it's more or less straightforward. And you see that you need the lift to drag ratio here in this equation, right? So we can assume that you probably get a pretty good range with the best lift to drag ratio, which means that you just need this point here.
He explained many more equations and how this worked in depth, but I don't want to bore you guys with the specifics and it would make this video very long as well, which is once again why I put it on Patreon. But for this equation he talked about, he found an online calculator where you can add all of the numbers and it'll calculate it for us. So that's very useful. We don't have to do it all by hand. Now, in order to calculate this and many other things, we need to get that drag polar. This can be roughly found inside of OpenVSP, which is why we want to create the concepts in there. It's very easy and quick to make stuff in there, and he's going to give us a quick tutorial on how to do this. But before I show you that, let's have a look at how the trailer is getting along. So, I finished the spaceship and it looks alright. I mean, I spent 2 hours making it. I don't know if it's worth it. But now I'm adding some solar panels. The spaceship looked too skinny for my liking, so I just duplicated it and stuck another one to the bottom. I also put a battery on the spaceship for the part where it says
an endless source of energy.
So I made a quick animation for it all, which looks like this after I rendered it. And then for this part,
energy, which can be used to outshine any competition.
I want to create some weird beam light unit that retracts underneath the spaceship and shines a strong beam of light and turns it around a bit. So I made that, and here's what the animation looks like. And then I rendered the whole thing, and here is what that looked like. I then made this extra shot to be used in another part, and I also wanted to make something for where it says this.
Why would I let anyone steal my solar panels? They're expensive after all.
And I want to make an animation where the solar panels detach from the spaceship and all the lights turn off. I spent an hour or so animating that, making it look realistic like in space. And I do like the end result. It's just kind of weird that the spaceship is staying still, but I'm not going to change that, it's too complicated. Then with all these shots, I was able to start putting everything together inside of Premiere Pro, which honestly did all the shots and the script so much justice. But before I show you what I came up with, let's go back to the OpenVSP explanation first.
Does OpenVSP have a file sharing ability, or is it all stored locally?
All locally. So my team and I, we just use OneDrive to share designs.
Yeah, okay, that makes sense.
So let's just make a basic design from the start. So in the geometry browser, you can choose the different things you need for an aircraft, right? And we'll just add a fuselage. I'll use millimeters as the unit. So I think one important thing here is the X section, where you can define the different sections of the fuselage. This section here is super tiny, so let's make it bigger. So that's this section, and I'll just copy this one, paste it for the next one. So one interesting thing maybe is that you can choose either here different shapes, or what you can also do if you want to make it custom, you can click here on Convert C-Edit, and then in this here you can specify the shape as you want.
Oh, that's really cool.
And something else that's quite useful is to activate the right-left symmetry so that it's always symmetrical.
Doesn't seem too difficult to use, really.
Yeah, so that's why I also recommend it, because if you want to iterate on your design, you can make it pretty quickly. And something else that's also important is the skinning thing here. Here you can set the curvature mostly with the strength here. So it bulges up if you make it bigger, or it's pretty flat if you don't. So now this endpoint is defined as a point, and I'll just make it a circle. That way I can, for example, if I have a EDF in here, I can, I guess, model it more or less like this. And if you click here on shade or texture, then you can see it like this. I guess more or less the same thing for the wings. Yeah, I'll just first adjust the span to 1.8 meters, for example. Now it's visible. Now it's super slim as well, right? Here I can adjust the root chord and tip maybe as well. And then in X form, you can adjust the location in X-axis, I guess something like this. And here you can adjust the airfoil also with the edit, for example. And yeah, it's super convenient to just prototype quickly. Another thing that's probably relevant is the vertical stabilizer. So it's just a wing. Yeah, want to make a vertical stabilizer out of it, you just have to adjust and you need to rotate it. So it should be symmetrical around the XZ-axis and rotate around. But if you want to have two vertical stabilizers, for example, at the angle, you can just do it. And then it's also, again, symmetrical around the XZ-axis. And then, so the last thing, VSP Aero. Let's say you want to test this design. Then you go to Analysis, Aero, and VSP Aero. Make sure for the case setup that you selected the vortex lattice method, the VLM. The reference area, you should get it from the model, or you can just read it out. So we just have this wing here, and the reference area is 23,000 square millimeters. So the reference area, that's also something that confused me for quite a while. If you have a few, so that's the view from top. That's your vertical stabilizer, that's the fuselage. The reference area is defined over this entire area. Also including the part that intersects the fuselage. Yeah, you just make sure that you select the right wing. So if you have a vertical stabilizer, you would also be able to select it here. Then for the moments, you need the center of gravity, and you can just make it auto-calculate with this button here. And I guess this just assumes equal density everywhere, which is not correct, of course, because where the battery will be, there it's going to be more dense. But for a first estimate, it's okay. I mean, if you either build a prototype or if you model it in CAD, then you can get the center of gravity more precisely, and then you can type it in yourself if you know where it is. Right. And then the last thing you need is the flow conditions. So let's say you want to fly at 122 kilometers an hour. So what you need is the angle of attack. We need the sweep from minus 10 degrees roughly to 10 degrees, for example. And we'll use 11 points for that. Beta is the side slip angle, so that how much the wind comes from the side. And we just use 0 for now. And we'll just set it at one speed at 70 kilometers an hour, which is Mach 0.06. Right. And then, so if you have all these things done, so that's the VLM method, the reference area and length from the model, the center of gravity, and the flow conditions, you can launch the solver. And so that's also related to the discussion in the chat regarding CFD. So OpenVSP is way more faster than CFD, which is why I don't recommend working in CFD in the near future. So here in the results manager, we can go to the sweep tab, and now we already see the drag polar.
So now that we know how to do that, we are able to start trying a bunch of different plane designs and figuring out what the best design is for us. Because if you didn't know yet, this design is not finalized and it may end up completely different. But that's all being worked on as we speak right now. But let me show you what the trailer looks like up to now.
What if you have an ambition, one that most consider too ambitious, telling you the drawbacks and the likelihood of failure?
People are already doing that, who are smarter than you ever
Large
will.
corporations invest millions to this. You will need
How would you even sell that? You aren't even studying aerodynamics.
How will you ever compete? But what if failure correlates to realistic thought? And what if ambition correlates to success? What does smart even mean when IQ predicts academic success and intelligence doesn't correlate to wealth? I think that ambition is great. Ambitions make the future something to look out for. In my eyes, ambition is the sun to my solar panel, an endless source of energy which can be used to outshine any competition, to work out every issue you see and find a solution, to rapidly learn whatever is on your path, to have an advantage over anyone without continuous energy. Why would I let anyone steal my solar panels? They're expensive after all. Instead, I will build more solar panels, and I will show the world what the sun is capable of. But what is my sun? Introducing Navius. Engineering, developing and selling the most capable transportation UAV at the lowest cost, with each drone carrying 5 kilograms worth of whatever the customer needs.
I'm honestly very proud of what it looks like. As I'm speaking right now, it's actually Monday though, meaning I wasn't able to finish the entire trailer this week, along with this video. This is because I was carrying a lot of weight on my shoulders on managing all of the projects and delegating tasks to people on the server. This was really becoming unhealthy, but I did not want the server to seem too corporate, as people are just volunteering, and I thought that something corporate could be off-putting. But last Friday, I really had no choice anymore. I made an announcement telling the other members that I was overworking myself. People in my private life are worried about me, and I'm worried about myself as I'm unable to do anything at this point without thinking about work or being stressed. I know that it's not healthy, and if I want this to become a successful company one day, then I need to be healthy at least. And I guess being more corporate is more respectful to the work that is being done by the people. At this point, everyone actually responded very nicely to it and started making a list of things that we can do to make everything work smoothly, to the point where I can just focus on making these videos, raising funds, getting exposure, and the entire business side of things, as that's where most of my potential is at. And so that everyone would be able to focus on engineering and all of the workload is distributed over everyone, making it very minor instead of all of the workload on one person. Then Josh actually started implementing all of this. And by the way, Josh is the very first person that reached out to me to help on this entire project, and he is honestly amazing ever since. He started making an application form, and I made a business email for applications so that if you want to apply, you can just fill the form in anytime and people can read what was said and plan in a meeting with you. For now, it'll just be me checking that out, but maybe in the future, other people can do that as well. Then Josh divided everything up into 5 different departments: aero design, electronics design, project coordination, social and marketing, software development, structures and mechanical design, and a collaboration between 2 of these departments for propulsion. This was also recommended by Jonathan, who is also leading a team like that, and he said that making different departments is actually very useful. Every department has a team leader and a second in command. They will be in charge of setting goals each week and delegating tasks between members. They will also put all of the progress they've made in a special channel where I can go over each week for the video and show you guys what we've done. And if 5 departments are all working on things at all times, then these videos will become a lot more interested and packed with a lot of cool stuff. I will also be having weekly meetings with the team leaders to go deeper into the specifics and discuss what has to be done. And here and there, I will probably also join in on some of the progress that is being made, or talk to some people, like I had some calls in the Aero team already, because I love learning these things and knowing what's going on. We did so much more, but this video is getting too big. It needs to be uploaded today. All in all, we are still dividing members into different departments. Progress is already being made in a lot of the departments. There are team leaders already, and we are now able to handle potentially your progress way more respectfully, and it's easier to contribute to this project. So if you want to join in on anything, please apply with the link in the description, but please only do so if you have enough time on hand, because we really need people that can do stuff instead of only talking, because of course that's very nice, and if you're very smart you should also apply, because we do have like an advisor role, but we really are looking for people that are also able to do things and actually design stuff in OpenVSP, for example, so we can really start making more progress even faster, and it'll be so cool. So please, if you have time and you want to do this, then please apply, and I will see you guys next week.